Assalamualaikum. This presentation for ECS436 Material Task 2. The group member is Muhammad Muzammil bin Zuki, Muhammad Syakban bin Hashim, and Muhammad Izzuddin bin Rosli. We are from class 3B2. Let's start with introduction. Seashells of various mollusks such as oyster, clam, mussel, and scallops are available abundantly along coastal areas in Indonesia. Various physical, mechanical, and chemical properties of shells such as cockle, oyster, mussel, scallops, cribidule shell, and conch shells as a sand displacement, a partial and total cost aggregate displacement, filler, and cement replacement in a form of complete, crushed, ground, or powder have been studied previously. As a sand replacement, the waste oyster shell fill material pores, reduce the absorption rate, and produce a comparable strength with the normal control concrete mix. The crushed shell have better permeation properties than the concrete without shell. This is partly because the shape and configuration in the mixture could reduce the tortuosity of pores in concrete. The crushed shells, as a coarse aggregate replacement, produce low-strength and lightweight concrete that is more suitable for low-strength applications such as concrete paver. Lastly, the use of ground seashells as a partial cement replacement is less favorable in application, since the production of shell powder requires intensive energy to burn and grind the shell as a fine-grained powder.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Izzuddin bin Rosli. So today I would like to talk about my topic, which is seashell as a new composite material. I will explain about result and discussion. For the result, we have 4 type of tests that do for the seashell. So first one is compressive strength, second one is a tensile strength, and third one is a flexural strength. Last one is a modulus of elasticity. Okay, for the compressive strength, as you can see from the table on the top, for the we have a ground seashell percentage and compressive strength. So for 2%, we have 30.84 for the compressive strength. Second one is for 4%, we got 32.24. For 6%, we got 28.86. For the last one, for 8%, we got 30.56. So as you can see from the below graph, we have a compressive strength versus age of concrete graph. So the black one is a OPC and the grey one is OPC plus seashell. So for the 7 days, we can see that the OPC is more strong, and the second day also same, and for the third day also same. So for it means like the OPC is more strong than the OPC plus seashell. So next is for the tensile strength. So for the tensile strength, as you can see from this graph, the black one represent OPC and the grey one represent OPC plus seashell. So this one is the same as last one, age of concrete versus the tensile strength. So for the 7 days, it almost same for both of type of OPC, and for the 28 days, OPC is more lower than OPC plus seashell. So, and for 91 days, OPC plus seashell is more better than OPC. So for the tensile strength, we can see that OPC plus seashell is more better than normal OPC. Okay, next one is for flexural strength. Okay, for the flexural strength, we still got age of concrete versus flexural strength. Okay, still the same. Black one is for OPC and the grey one OPC plus seashell. For the day 7, almost same. And for the 28 days, we can see that the OPC plus C-shell is more better than OPC. For the 91 days, OPC plus C-shell is better than OPC. So from this graph, we can say that OPC plus C-shell is more better than normal OPC at the flexural strength test. So last one is for modulus of elasticity. We can see this. That there's at the day of 7, OPC is more better than OPC plus C-shell. So same as 28 and 91. So for modulus of elasticity, OPC is more better than OPC plus C-shell.
Feedback from society. From this part, we are separate into two sections. Section A, knowing the composite material. Section B, usage of C-shell in composite. We provide 3 questions in Section A. The level of knowledge about knowing composite material is from 1 to 5, which is 5 is the highest understanding. The average response for this section is highest, so I can conclude that the society already know about composite material. For section B, we provide 5 questions only. The level of knowledge about usage of C-shell in a composite is from 1 to 5, which is 5 is mean totally agree. Based on data, over 50% of the community know that the composite material and agree with our material use C-shell in concrete mixings. However, maybe has a few community not surely agree with our material use, but it just in a lower percent. Material and method. The ordinary Portland cement type 1 was used as a main binder. Fine aggregate, fineness modulus, water absorption was used. Coarse aggregate and water absorption was incorporated as the main component of concrete. The seashell were collected from the local seafood vendor. The shell were cleaned, dried, burned at the brick furnace, crushed into the small pieces using Los Angeles machine, then grounded with a blender, and sieved to produce a seashell powder. The seashell were burned at a high temperature for 3 days.
Conclusion. In this study, the effect of replacing cement by ground shells on the mechanistic properties of concrete was examined. Replacement of the cement with the ground shell lead to a decrease of compressive strength of shell concrete compared with the controlled ordinary Portland cement concrete. The tensile and the flexural strength of the shell concrete were higher than the controlled ordinary Portland cement concrete. The Young modulus of elasticity of shell concrete increased with the age of concrete. So, we can conclude that the concrete containing ground shell yielded relatively better tension properties, but lower compressive strength and modulus of elasticity than the controlled ordinary Portland cement concrete.